Have you ever made a paper airplane and launched it across the room? Maybe it soared across the classroom, or maybe it crashed right away. Either way, paper airplanes aren't just fun, they're a simple way to test out real science. Engineers who design real airplanes use something called aerodynamics, the science of how air moves around things. A good paper airplane needs to be aerodynamic. That means it cuts through the air smoothly and doesn't slow down too much because of air resistance. Some designs are built for distance. They have long, narrow wings and pointed noses. Others are built for tricks, with wider wings or special folds that make them loop and spin. And even small changes can make a big difference. A tiny fold in the wing or a heavier nose can totally change how a plane flies. Before flight, it's important to test and observe. Scientists and engineers do this all the time. They try different versions of something, collect results, and compare what worked best. That's called a fair test, when you change one thing at a time and measure the results. In this activity, you'll be the engineer. You'll build and fly two different paper airplane designs. You'll keep everything else the same paper, same thrower, same space. The only thing that should change is the design. Then, we'll turn your experiment into a writing challenge. Here's what to do. Make your two paper airplanes. Remember to keep the paper the same for both, but to use two different designs. Then, with your teacher and your classmates, throw both of your airplanes a few times, recording notes about them. After you fly them a few times each, it's time to look at the results. Which plane flew farther? Which was more stable? Which one surprised you? You're going to write a compare and contrast paragraph about your two airplane designs. Start with a sentence that says what you did. Tested two paper airplanes. Describe the first design and how it performed. Describe the second design and what was different. Compare how they flew. Which one flew farther? Which was more stable? Use linking words like however, both, or unlike. End your paragraph with a sentence explaining which design was better and why. Use clear language and be specific about what you observed. Remember, you're not just telling which plane won, you're explaining why.